In this video, we're going to look at mechanical energy. Now, mechanical energy is a really important idea, and it's the idea that the total amount of gravitational potential energy and kinetic energy is going to be the same at the beginning and at the end and in the middle of a system. So your formula is essentially mechanical energy equals potential energy plus kinetic energy. And we've spent some time looking at potential and kinetic energy. But we can imagine, and sort of the classic description is, if we had a pendulum and the pendulum was raised up a height. So at this point, our pendulum, we could calculate the potential energy. But let's say that it stopped. We could calculate its kinetic energy. That would be then zero because it stopped, right? So at this point, the mechanical energy is all potential energy because there's zero kinetic energy. But down at the bottom, where we've got the pendulum is moving the very fastest, so this is the fastest it's traveling, the mechanical energy is still the kinetic energy plus the potential energy. But in this case, because the potential energy is at the bottom, the kinetic energy is the only kind of energy contributing to the mechanical energy. And so as long as we're not losing any energy as heat, so this is assuming no loss of energy as heat. So that would be a product of friction. So friction causes a loss of energy as heat. If we assumed that there was no friction, then the potential energy at this point would be the same as the kinetic energy at this point, because at the top, the pendulum isn't moving, and at the bottom, the pendulum doesn't have any potential energy. And any point in between here and here, the total mechanical energy is going to be the same value. So if we could figure out what the halfway mark was here, then at this halfway mark, the kinetic energy and the potential energy still are going to equal that same mechanical energy. But if it's halfway up, that's half the potential energy. So there's half the kinetic energy. So it's going to half the speed. And so mechanical energy questions are looking at the connection between the potential energy and the kinetic energy at any point in a system. So here, if we had a ridiculously large water balloon, so this is a 10 kilogram water balloon. That would be a very heavy water balloon. And it is dropped a height of 12 meters. If at the start it's not traveling at any speed, the mechanical energy equals the potential and the kinetic. But if the kinetic is zero because it's not moving at the top, then the mechanical energy is just the potential. And at the bottom, the mechanical energy is going to be the kinetic plus the potential. But because it's right at the bottom, the potential energy is zero. So at the beginning, the potential energy will be equal to the kinetic energy at the end. Because the total mechanical energy would be constant, assuming that we don't lose any energy along the way. So here it says that we've got a massive 10 kilogram water balloon. It's dropped 12 meters. Determine the speed of the balloon just before it hits the ground. Well, potential energy is mgh, and the kinetic energy is mv squared over 2. So remember that kinetic energy equals 1/2 mv squared in the data booklet. I like to write it like this, as I mentioned in another video, because I feel like it's a little easier to rearrange. So it's asking us, though, to find the speed. So I'm going to rearrange this, and to get the speed squared by itself, my 2 is going to go up to here, so I get 2 mgh, and my m is going to go down here, so I've got m. That'd be v squared. But you'll see that my m's are actually canceling out. The mass of the balloon didn't change. So v squared equals 2gh, and so v equals the square root of 2gh. And so the speed is going to be the square root of 9.81 meters per second squared times the height, which is 12.0 kilogram, or it's not kilograms, meters. And so the speed is going to be equal to oh, and I didn't put in the times 2. Sorry, that's my mistake. Because the speed equals the square root of 2 times those things. Sorry. So this gives me 15.344 and a bunch of digits meters per second. So I had 3 sig digs here and here. And so I'm going to be using the 3 sig digs for the speed. And so that's kind of how you do mechanical energy questions. So in this question, it says, according to the law of conservation of energy, the gravitational potential energy that dropped a ball starts with is equal to the kinetic energy just as about to hit the ground, as long as the air resistance is small enough to be ignored. Use this to determine the speed of a 5 kilogram ball. So the mass is 5.0 kilograms. The height that it's falling is 3.7 meters. So it wants the speed again. So I said determine the speed. So if the top, the EM, equals EG plus EK, but the EK is 0 because it's not moving. And then at the bottom, the EM equals EP plus EK, but it's at the bottom, so it no longer has potential energy. Then my EP at the top equals EK at the bottom, assuming that no energy is lost. So MGH equals V squared, or MV squared over 2. And V squared equals 2GH. So I would have taken the 2 up here and the M down here. The M's cancel out. And so V equals the square root of 2GH. So the speed is going to be 2 times gravity, 9.81 meters per second squared, times, sorry, I'm running out of space here, times the height, which is 3.7 meters. And so the speed is going to be equal to 8.5 meters per second. Now in question 2, it's got a 1 gram ball is dropped from a height of 5 meters. So the height is 5.00 meters. What is the maximum speed of the ball? So that we want to know what the speed is down here, right? And up here, the EP equals the E mechanical because it's got 0 movement. Down at the bottom, the kinetic energy is going to be the mechanical because it's got 0 potential. So just like I was describing the previous examples. And again, they want the speed. So we know that the EP equals EK. So EK at the top equals the EK at the bottom. And so then my MGH equals MV squared over 2. V is going to equal the square root of 2GH. So it's the square root of 2 times 9.81 meters per second squared times the height of 5.00 meters. and I come out with 9.90 meters per second. Okay, so all of those examples have been pretty much identical. The other sort of thing that they could say, though, is it could ask you a question where you have a ball that's traveling up here. So we've got this ball is being thrown, and its initial speed is, I don't know, let's say 15.0 meters per second. And we'll say that the mass of the ball is 1.00 kilograms. What is the maximum height that it will travel to? And so again, down at the bottom, because it's got no potential energy, the EM equals EK plus potential energy, but the potential energy is 0. And at the top, we've got the mechanical energy is potential energy plus kinetic, but we're assuming that this at the top has stopped moving. So all of the energy has been put into making it reach a height. And so the EK at the bottom here will be equal to the EM at the top, or EP at the top. And so mv squared over 2 equals mgh. And in this case, though, I want to solve for h. So h is going to be equal to, I'm going to take my m over here, and I get mv squared over m, and then my g also goes down. And so I've got 2mg here, right? Because to cross the equal sign, my mass here is going to go to the denominator, and my gravity here is going to go to the denominator. Now my masses cancel out, and the height is going to be v squared over g. Oh, over 2g. Sorry, we had our 2 here. So v squared over 2g. And so the height that it's going to be able to go is going to be 15.0 meters per second squared divided by 2 times 9.81 meters per second squared. That's the acceleration due to gravity. So I get 15, I'm going to square that. Then divided by that, I get 11.5 meters. And so the other kind of arrangement that we could get is where it's asking us to calculate what the height is going to go, but it still has this relationship that the potential energy at the top is all of the mechanical energy, and the speed at the bottom is all kinetic energy, or the mechanical energy at the bottom is all kinetic energy because it's all speed and no height. So hopefully that helps make sense out of this.